All right, let's say we're combining some probability distributions and we are adding and subtracting some random variables x and y. Well, if we want to find the mean of this combination, is we simply just add the means of both x and y and we get our new mean. However, if you're asked to find the standard deviation, we just don't add the standard deviations together. No, we cannot do that. Instead, we take the variance. All right, we add the two variances together and then we take the square root. Because if you recall, when we talked about this earlier, is that standard deviation is actually equal to the square root of the variance. Okay, so when we have that right there, it's going to be x. In the same manner, if you subtract two variables, okay, we just subtract the means, but we still add the two variances together. Okay, we always add variances. Okay, always add the variances, and then we take the square root. We can use this is that we can now use our probability distribution model to find new means and standard deviations of these each. All right, so without further ado, let's try a problem. Check our understanding of this one. Now, a large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let X the number of cars sold and Y the number of cars leased during the first hour of business at a release of the day. Based on the previous record, the probability distribution of X and Y are as follows. So here's our probability distribution of cars sold, probably a distribution of cars leased. All right. We're going to define T being X plus Y. Assume X and Y are independent. So they're independent of each other. So from here, we're going to find this new, all right, mean T. Now to figure out this mean, we're going to take essentially the mean of X and we're going to take the mean of Y. We're just going to add those two values together. So we have 1.1, all right, plus 0.7, and what we have is 1.8, 1.8. So what is that? Well, let's interpret this. So the first hour of business of random 6 days. So from each one of these, the number of cars sold and number of cars leased. So what we have here is we expect to after many Fridays, all right, we expect the dealer to sell or lease around 1.8 cars. So remember, when we're finding this value right here, this mean, this is known as an expected value. So after many Fridays, we expect the dealer to sell or lease around 1.8 cars, because that's what we found when we combine these two, because X is the selling, Y is the leasing. Now let's calculate and interpret this standard deviation of T. Now the standard deviation of T is, remember, we're going to take our variance. Okay, so I'm going to take the variance of X and we're going to add that to the variance of Y, which would equal the square root of 0.943 squared plus 0.64 squared. And you would put this into your calculator, all right, and 0.943 squared, all right, plus 0.64 squared. And we would go, and I got about 1.1. 4. I'll go round to 4. Okay, 4 cars. And so what does that mean? The number of cars sold or leased on Friday, all right, on a randomly, maybe I should, on a randomly selected Friday, leased on a randomly Friday typically varies by 1.14 cars, all right, from the mean. And I'm going to keep on going down, all right, from the mean. And that's what we know, and that's what we got. And so what we have right here is the number of cars sold or leased on a randomly selected Friday typically varies about 1.14 cars from the mean. And so we have that, and that's what a standard deviation is. Okay, so now the dealership manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and standard deviation of the manager's total bonus. All right, so now from here, all right, what we're going to be doing is we're taking these different values and we're going to take this and we're going to essentially change this up because now we are changing the value that we're going to be taking all of our mean values right here, and for the cars that are sold, we're going to be multiplying by 500. So this value is multiplied by 500, this value is multiplied by 500, but down here we also have a bonus for lease cars, so this is going to be multiplied by 300. And this also is being multiplied by 300 because that's how we can do it from mean and standard deviations. Whenever you multiply those by those values. And so now it says, what is the new mean and standard deviation? Well, I'm going to just write this up here. All right, so you can see that. And so we have this new mean and standard deviation. We'll call this for total bonus B. Okay, so I'll say B. Essentially, that's going to be, all right, and you can see this right here. 1.1 times 500 plus 0.7 times 300. And we would take that and add them together. All right, and our bonus would be about $760. That's what we expect. Our standard deviation would be is the sum of the variances. And so we're going to take this variance, we're going to take 0.943 times 500. We're going to have to square that. And we're going to add that to our other variance, which is 0.64 times 300 squared. All right, and what we have there, we put in our calculator. All right, so you can try this out. 0.943 times 500. Make sure you put parentheses around all those different things. All right, and when you have that, and I'm almost there, 0.64 times 300, and I got about 509.09. All right, dollars. Okay, so on average, okay, on any given Friday, the typically the bonuses typically varies from the mean of 760 by $509.09. And that, my friends, is how we do combinations of different events. All right, well, I hope this helps you out, and good luck and God bless in the rest of your problems.